you about today is something we call LEX. And basically, a large part of what the Federal Reserve does is, especially since the financial crisis, is monitor banks, particularly the banks which are too large to fail, as well as smaller banks and foreign banks. One thing I have to say before I continue is everything I say today is this reflects my own beliefs and not those of the Federal Reserve. So, okay. So this involves on-site examinations where we send a team of auditors to the various banks. It involves all types of, we have something called enforcement action where we say you're not doing this thing according to the specs. You have so long to fix it, and we monitor it. And anything which may be causing worries or risks to the financial system. Because of the volume of documents, we collect probably close to 500,000 documents per year, and these documents can be rather large. This is just talking about our checking to make sure the banks are doing what they need to do for money laundering. So we go in, we check the procedures, and it turns out that this was the first area we wanted to see if using natural language processing could help the examiners go through all these documents and identify things that may be of interest to them. So we set up an experiment where we had the same reports go to our system and to a bank examiner group. And we also had people work together with us from supervision to come up with setting up rules to identify these. So we used a combination of two areas from that. We used the old-fashioned rules where we would say we want to find certain things and we would list them. And they need this so they can do attribution and auditing. But also we wanted to make use of word embedding because without word embedding, and for those of you that haven't heard of this before, it's a way that you can put a word into a vector space, and that's a mathematical term, but basically you could picture it into a group of words which have similar meanings. And you can take the distance between them, and I'll show you some representations of that later. But this way, you don't have to worry about keywords. You just express a concept, and it will match that concept in the document. So, for example, one of the areas which we're concerned with now is climate change and risks to bank. So if we put just the word anthropogenic into our system, you can see which words and phrases come back, and all these would be identified by that. So everything from greenhouse warming to atmospheric CO2 to terrestrial ecosystems, climate variations, global warming, greenhouse gas, and so on would be matched by any of these words. So if the examiner says, I want to look for atmospheric CO2, everything else on this chart and more would be picked up. But one of the things that happens if you do this is you get back too many matches, and you can get noise. So we designed a system that has something that's called a lexicon, which we'll explain later. This shows what a submission looks like. So if you want to look at that and read it while I'm describing the way the lexicon works, even though they're unrelated, it will save a little bit of time because we've got a lot to go through. But you can see when we get these packages, they have Excel sheets attached, Word documents, a lot of things. So we have to go through all this and scan it all. So to avoid the noise, we put logical conditions. So we might say something like global warming, and then we'd have an and to that, financial risk or volatility or loss. So we wouldn't pick up things unless it matched both the ecological effects as well as the financial effects. So one of the things that happened is that this experiment worked out very well. And about the same time as we were uh, completing what I call our success with money laundering detection and bank compliance, the pandemic hit, and this changed the way we could do our monitoring. We no longer could do on-site examinations, but we were still responsible for continuous monitoring. So what started out as a proof of concept and a gentle rollout became a pedal to the metal acceleration to put this into full production, because every area, and we did the top 10, and now we have 30 of compliance that we look at, we're now put through LEX, and all the continuous monitoring and financial analysis of the banks were greatly enhanced by having this tool. And it was through the cooperation of both technology, supervision, and many people. I think there's probably over 100 people working on this now that enabled such a rapid scale-up. This is basically a 30,000-foot view of how it works. And the preprocessor takes all these documents and all these different forms and converts them into a common format that's coded in something called JSON, which is a way of representing unstructured data in a somewhat structured way. You've heard of NoSQL databases and so on. That they work under similar principles. It essentially has keys and values, and the sentences are identified. And they're then, and also at the same time, I'll tell you a funny aside which affected the architecture. Not everyone at the Fed is used to using computer-based search tools, and a lot of them like to read documents on a computer, but they're still reading a PDF document. So they said, by the way, would it be possible for you to do what our readers did before, which was they had different stages, and the first group of readers read the documents, and then they highlighted the parts they thought would be interesting to their managers, and that would be passed up. Can your computer highlight the documents too? Now, they thought this was a simple request, but actually, it was one of the harder parts of the design because the PDF documents and Excels and all these things had various formats, and we had to keep track of the exact location on all the documents, these phrases. So we had to have a data structure which not only stored the sentences and the data that we were extracting, but page 37, character number 300, whatever, to identify the highlighting. And they would be very upset if we highlighted anything that we weren't supposed to. So, and you can see there's in the corner, there's what the document outputs looks like, and you can see that it's highlights, and they were put in by LEX. So after this whole thing is prepared and put in this JSON format, it then goes to what we call the LEX engine. In the beginning, we called it the NLP engine. They rebranded it. And what it does is it goes through all these rules and looks for the combination of words that match according to the similarity model. And one of the other things we discovered right away is we were using an open source word embedding model that was released by Google around that time. And it didn't have a lot of the words we needed because financial documents with acronyms and are also specialized or just different meanings of the word. In fact, one of the banks had the word, we were looking for things that had to do with loans, and they had put pawn in one of their lexicons, and it came back with a chess move. People said, what is this? And so we realized we had to make our own model. And we after a lot of negotiating, we're given permission to create our own word-to-vec model based on all the documents they have in their corpus. And this had another advantage besides bringing it up to speed with all the vocabulary. It also let us see when new vocabulary was being introduced, which we train this on a monthly basis, and that shows new areas of concern from the banks. So it's one way of detecting like what people are thinking about before we ask the questions, because we get this new generated vocabulary list, and then we say, does this belong in some of your lexicons? People say, yeah, we should do that. And it does one of the things which people ask for and almost never get, which is to discover unknown unknowns. So that's just an advantage of continuously training or training on a periodic basis. So this is just to talk a little bit more about the very basics of WordDirect. I wish I had time to go through the algorithm because it's very elegant the way it works. But you may have heard there's a distinction between supervised and unsupervised learning, where supervised learning is where you have an answer to compare to, and unsupervised is where you don't. And this actually makes use of something that some people refer to as unsupervised supervised learning, which sounds a bit like an oxymoron, but they discovered that if you mask a word in a sentence and have the computer try to guess what it is, or if you want to do generative text, you want to see what the next word might be, so maybe you leave out the last word in a sentence, and you try to guess, you've now created a supervised problem because you've masked out something. But at the same time that you mask it, you know what the answer is, and you can put that in the column that says target. And by using a neural net to solve for this, you can take the last layer of the network, and that is the vector that represents the word that it was trying to guess after it finally learns. And that's what creates the word embedding that we then put in the 300-dimensional space that makes this magic happen. Now, I hope you can read this. Is it legible? So this is produced by a technique called t-SNE, which allows you to focus in on a little bit of the model. And even though it's a three-dimensional data structure, it reduces it to 2 dimensions. So you can see basically how these relationships work in terms of distance. So if you look at where the capital adequacy, which was what it was centered on, you can see that capital planning and stress test is right nearby. That stress testing, capital planning, recovery, resolution planning, and all the things that would make sense to someone looking at the capital adequacy are represented there. Similarly, if you look at CCAR, which is at the top, which is one of the things that we require banks to do, which is a stress test, there's a similar one called DFAST. And if you look around that, you see the terms which have to do with those things. So imagine when you're searching for something, you don't have to be that precise. You just have to get somewhere in the neighborhood of what you're interested in. And this algorithm will find it. And it looks pretty good in 2 dimensions. It's that much better in 300 dimensions, even though it's hard to visualize. Impossible. So again, this talks about the difference between creating your own domain model versus using an open source model. We had a 20% increase in the number of relevant words, and that's important because if you're missing a fifth of the words that are important to you, you're in trouble. And we have a total vocabulary of now 3.6 million words. And both of these concepts were not in the Google model, and many ones weren't. So if you put in capital adequacy, it would just come back without a vocabulary. But with the trained model, you get things like capital planning, adequacy, poor stress, capital ratios, and other things which you would be interested in. Now, the structure of the lexicon, we can't show much of these because it's proprietary information, but just to give a little bit of a look, you have different columns, and you can have as many columns as you want. And essentially, the columns show a relationship where everything must be present. So if you have 2 columns, it's an and between the first and second column. So in this case, you would have to have something which related to money laundering, or the abbreviation AML, which is also commonly used. And then also have something in the sentence which relates to it being suspicious, or activity, or a violation, or a concern. And each one of these words would be put into the model and expanded. And it casts a wide but sort of specific and targeted net. The Boolean combination of these terms reduces the noise. And so you get the depth where you want it without getting things that you wouldn't want to receive. So this is the process we went through to validate it, because just because it works doesn't mean that it's working correctly. So you have to validate. And this is where we cycled through these, review, analysis, and action over and over again, having people write the lexicons, comparing it to a control group, which went through the documents the way they used to, and then seeing what was in common. And we did over 80% of what the people did. And then we found things that they didn't find. And actually, some of the things that we didn't find, they didn't think were that important. So they were very happy with it, and it reduces the time for just one area and one bank from several weeks to less than a day. So we do. This is a more complex lexicon. Typical lexicons are about 38 lines and have between 2 and 3 columns. And the type of trigger is also recorded. So you can later do database analysis of what types of violations and what types of enforcement actions or other things of interest are coming up per bank, and you can make a time series of that. We have a dashboard which shows, in this case, the relative number of fines that were for a particular query by bank. And in this case, we're looking for cloud adaptation, staying within budgets, and overall strategy issues. And below that is a time series. We are improving this. Part of the peaks are based on quarterly filing dates, so it's a bit distorted, but now we're trying to get more accurate date sources by going back to actual dates picked up off the documents rather than the dates we received, and smooth that out. And again, this is where you can sort by various things, like how many fines, what particular fines, what triggers you're looking for. Go to the document, push the button, then see the document with the, not only do we have the highlights in yellow, but we also create an index which directly links to the sections that you would be interested in. And this is what the highlighted output looks like. We also store the same JSON output into a database, which allows Tableau integration. And this way, you can look at all the different triggers that are used in the lexicons, as well as the attributes, which is the second column. They're logically the same, but people think of them differently. And then you can see which reports come up, and then you can drill down. You can eliminate. You can say, I want it with this trigger, but not that trigger, and make more complex, on-the-fly Boolean relationships. And finally, we have a sandbox for authoring. So when people create the lexicon, they often want to know what effect this word will have, what effect that word will have. They can put in their own test documents and try it out, and it helps them understand how the model works, how the search works, and gain a facility. Because one of the things we ended up having a shortage of right away were lexicon writers. And we helped them a lot in the beginning. Then we had classes where we taught them how to create lexicons, and now we have over 30 different risk areas modeled through this process. And this is just more graphics showing how it works. They can type in the words, they can read in a document and see what comes back. In this case, it gives the matches that came back. So they also, actually in this case, they're just understanding how the model works. So they would type in a word like backlog, and then it would set a threshold, and then it would come back and show what words would match that, which again helped them in the creation of the lexicons. And these are some of the use cases with climate risk. The pandemic was a very important one because we're also monitoring how the funds were being spent, that were being provided by the banks for pandemic relief, as well as what risks were created to the banks and the financial systems. And climate risk was also called for a lot, and that was one of the next ones put into production.